Very good morning, students. Today, we are starting a new lecture series on the subject Big Data. The subject code is KOE 097. So, we are starting with the very first unit, and the first topic is Introduction to Big Data. This is the list of topics which we will cover today. The contents are Introduction to Data and Information, Sources and Examples of Data, as well as the big data, the business analytics, business intelligence, big data and the data mining. We'll discuss about the comparison of all these four terms. Then we'll start with the characteristics of data for good decision making. It is used in business intelligence. Then now we'll talk about what is the actual meaning of big data, 3 V's of big data, 5 V's of big data, as well as 6 V's of big data. After that, we'll compare the big data with small data, the major players or the companies dealing with the big data analytics, the different kind of tools, as well as at last, I will put up a question for you, few questions for you to answer yourself. So, we'll continue with this part. So, let's start with the very first topic. What do you mean by data? As all we know, data is something which has some meaning or value, like my name, my contact number, all these terms are data. I have taken an example here, 1025 Ghaziabad, or some roll number of a student, some email ID or anything else. All these are called as data. The data is different from information. Data may be a raw data, which means it may or may not have some utilization value. But information is something which has a logical relation, which is useful, which has a particular meaning. So now you can see here, it is an information which contains only the numeric data. But this kind of data contains mixture of numbers, alphabets, email ID. So it can be a raw data. We have to extract information from this data. So now this particular information has some meaning. It is a kind of a homogeneous data. So now how large your data is? As we are talking about the big data concept, so we have to think about how large a big data can be and what is the difference between a data, normal data as well as big data. So what is the maximum file size you have dealt so far? Maybe a movie up to few gigabytes, maybe any Word, Excel file, maybe up to some megabytes, or any live streaming video. So this is the data which can be in GB, MB, or you can say TB, terabytes. So the data can be in any kind of size, but big data is much larger than this size of data. So what is the maximum download speed you get? As like you are using 5G connection or satellite internet connection, so you are getting very high speed of internet downloading as well as uploading. But what is the maximum speed? If I'll take my own example, I use up to 30 Mbps speed of internet in download and up to 15 Mbps speed in upload. But this is not a very large speed. The large scale organization has the internet download and upload speed in gigabyte or many gigabytes. So the data which is used to retrieve some data stored in the distant locations, far away locations, need maximum speed to download the data. How fast your system's computation means the CPU, at what frequency the CPU is working, how many number of instructions it is processing. If you are using a microprocessor, that means 10 raised to power minus 6, it is processing 1 million instructions per second. So if you have a nano computer, that means 10 raised to power minus 9. You have 1024 million instructions per second. So that is the computation speed. But on workstation, on very large scale projects like nuclear power plants, nuclear reactors, weather forecasting systems, or you can say stock exchange markets, they operate at more speed as compared to this speed. So in big data, speed, size both matters. These are the few examples which I have already told you. Kilobyte means 10 raised to power 3, megabyte means 10 raised to power 6, gigabyte means 10 raised to power 9, terabyte is 10 raised to power 12, then petabyte comes, zettabyte comes, as well as at last yottabyte. Yottabyte has the size of 10 raised to power 24. So big data contains maybe 1 or 2 EB of data. Now the growth of data. I will give you a very interesting example, a very important statistics. In the last 5 years, if I'll talk about from today's date, in the last 5 years, the 95% of the world's data is generated. If I'll take example of only one company, say Domino's, it is an international company, it has thousands of outlets all around the globe. So every single day, the Domino's generates 3 to 4 petabytes of data, and they retain this data for 1 year in their system. Means they are generating 4 petabyte data every day, and the for next 365 days they are utilizing this data for business intelligence. So now how they go to such large amount of data in one day? Like if you visited a outlet and you have given your mobile number, your personal detail, they have entered into their system. So that means you have given your data to them. You have given your credit card information through which you are making a payment, or your digital wallet information. So all such kind of data is given by only one customer visiting only for one time. So now if thousands of customers are visiting thousands of stores every day, say petabyte of data is generated. So this data is very useful for the companies. They sell your data, they share your data with other companies and take a benefit from them. These companies utilize your data and provide you some customized recommendation for their business improvement. Like you are visiting through Google Maps at particular location. So your tracking data can be stored in Google account. You are visiting websites data in YouTube, your visited videos, your Facebook account, your Twitter, your tweets, everything comes under this. So the growth by a factor of 44. Every year the data is increased by 44 times. So in 2009, only 0.8 zettabyte of data was available. I will give you the statistics of 2020. 35.2 zettabyte of data is available till date. So you can compare within 11 years only 0.8 to 35.2. So 44 multiplied speed of growth of data is there. So terabyte, petabyte, zettabyte and zettabyte. Now from where such kind of large amount of data come? I have given you few examples of the data like tweets or sensors data, IoT devices data. So every day we create 3.5 quintillion bytes of data. So much that 95% of the world data has been created in last 5 years only. I have already given you this statistics. 95% of the world's data is created in last 5 years only. So the data may come from many sources, like sources used to gather climate information like GPS or other sensors data, posts to various social media sites like Facebook, Twitter, LinkedIn, Instagram, etc. The digital pictures and videos on various platforms like YouTube, Facebook and many other websites. Purchase transaction record. Every day how many number of digital transactions are going on in any way. Purchasing is done. That data is stored as a source of data. Cell phone GPS signal. Everyone is using maybe 1 or 2 mobile phone numbers, and every second a large amount of data is being generated. So these are the few sources of data. There can be many other sources of data from books, from video lectures, from discussions. So there are so many sources of data. Now see few examples. Social media and networking data, scientific instruments, mobile devices, and at last sensor technology and network in agriculture, in satellite system. There are so many areas where data is automatically generated each and every time. So these are the few examples of the data. Now the difference between business analytics, business intelligence, big data, data mining, what is the difference or the comparison between them? Business analytics means tools to explore past data to gain insight into future business decision. So it is a tool which helps you to explore the previous data through data mining or data warehousing concept or Hadoop architecture concept, and you can generate new business decisions from this data. BI means business intelligence. These are the tools and techniques to turn data into meaningful information that can be beneficial for persons, for organizations. Now what do you mean by big data? The data sets that are so large or complex that traditional data processing applications are inadequate to control them. So like zettabyte of data, it cannot be controlled by normal data structure or normal DBMS. Hadoop architectures are required to process such kind of big data. You can say data mining. These are the tools for discovering patterns in large data sets. So it is used for business intelligence, data mining. So all these terms are interrelated, but they have their own unique meaning as well. So now business needs support for decision making due to uncertain economic reasons, rapidly changing environment, as we have seen the COVID scenario in the last 2 years. So there is a very large amount of change in the business environment or economic factors of various countries. So the global competitions are there. The demanding customers are always arising. The needs of the customers are also changing day by day. So such kind of uncertain things need some support system to increase the business in market. So taking advantage of information acquired by companies is critical success factor. So nowadays companies like Google, excuse me, companies like Google, Facebook, Twitter, they are using our data to improve the business of all organizations or some other organization. I will give you one very interesting example. So if you are looking for some hotel on GoIbibo website, in the same device your Facebook account is logged in. So same Facebook account will reflect you the same kind of recommendation of hotels within a fraction of second. You visited on Google Chrome, but the same hotel recommendation is coming in your mobile device in Facebook or Instagram. Surprisingly, if your Facebook account is open in another desktop, not on your mobile device, that device is also showing your recommendation, same kind of hotel recommendation. It is all because these all companies shared your data together. They share the data, they generate revenue from this. So now characteristics of good data for decision making. So if the data should be of good quality, the decision making should be of good quality. So if the data is of poor quality, the decision made on the basis of that data is of poor quality. So I have given here 6 characteristics. So there are 6 characteristics which will talk about the better quality data. Number 1, accuracy. The data should be very accurate enough for intended purpose. The purpose for which you are utilizing the data, it must satisfy that purpose. So the data should be accurate. Second is validity. The data should not be expired or outdated. The data should be valid, so only that the business intelligence or business information can be generated from this data. Reliability. This is very important. Reliability means data should come from a reliable source. No fake data or wrong data should be used for decision making. Timeliness. So it is mainly used to influence the decisions. We capture quickly after the event and available quickly, it is enough and available frequently enough. So you need to take care about these 3 points. The timeline should be very important for good decision making. Now the relevance. The data should be relevant as well. It should used for intended purpose. The purpose for which you are utilizing the data, like you are making some business intelligence on stock market, the data should be intended for stock market users only. Then there should be periodic reviews of the requirement, quality assurance and feedback process should be there. We need to use carefully for some other purposes as well. The data should be complete in nature. No partial or half data can be used for good decision making. The data should be complete in all aspects. That is the last characteristic of a good quality data for good decision making. So you need to remember all these 6 kind of qualities for a good data. Now, data is big data. There is no single standard definition for big data. Big data doesn't have any new dimension or characteristic. The big means the large size only. It can be similar to the small data but bigger in size. Big generally means the size parameter in zettabyte, terabyte, not in megabyte or gigabyte or kilobyte. But the data should be like same audio data, video data, picture data. So the data should be bigger, but having data bigger consequently require different approaches or techniques, tools and architecture. So if you want to deal with big size data, you need various kind of tools and architectures for them. Now, what is the use of this big data? big data can be used to solve new problems, and of course in a better way. Big data can solve very large amount of problems in a better way, which cannot be solved by smaller data solving approaches. So I have given one standard definition. Big data is data whose scale, diversity and complexity require new architectures, techniques, algorithms and analytics to manage it and extract value and hidden knowledge from it. So you can analyze the data, you can perform business intelligence, and you can extract knowledge from the big data. Big data means that the data is unable to be handled and processed by most current information system or methods. Data must be handled by latest architecture, not by old kind of structure. Most of the traditional data mining methods or data analytics developed for a centralized data analysis processes may not be able to be applied directly to the big data. Now, very important part, 3 V's or 5 V's or 6 V's of big data. V means the basic characteristics. When the concept of big data was introduced, 3 V's was introduced about big data. These 3 V's are volume, velocity and variety. Volume means large amount of data. Velocity means needs to be analyzed very quickly at a very fast speed, and variety means different type of structured and unstructured data. Especially big data deals with unstructured data and multi types of data, not simply structured data. So the volume, velocity and variety, these are represented by speed and complexity as well. So now you can see here, this is another pictorial representation for the same thing. Variety means standard, structured or unstructured data. Velocity means the data should be processed at a very large speed, maybe say terabytes of the speed processing by the processor. Now volume means zettabyte or zettabyte of data. So these are the 3 basic V's of data. Now V1 I'll explain in very detail. It is a volume of data which needs to be processed is increasing rapidly. More storage capacity is required to store large data. More computation powers are required. More tools and techniques are required to process such large amount of data. So this is a statistics for tweets made per day. These are rising at a very high speed. Every day, so many new users are registering on Twitter. They are making so many tweets. So the data of tweets is growing exponentially high. Similarly, data storage growth. 1 petabyte is equal to 1024 terabyte. Nowadays, the data comes in zettabytes. Every day, so many videos are uploaded on YouTube. So many news broadcasting channels and satellite stations are there. So they are generating very large amount of data every single second. Next is your variety. The data can come from some social media. The data can come from some genetic factors like medical data, satellite data. Data can come from various kind of sensors or applications. So a single application can be generating many types of data. So that means variety. Data can be static or dynamic in nature. Dynamic means the data is streaming, as well as to extract knowledge. All these types of data need to be linked together. Only then we'll get the benefit of big data analytics. Third V is the velocity. At what speed the data is processed. So data is being generated fast and need to be processed fast. Otherwise the whole concept will fail. So for time sensitive processes such as catching any fraud, big data must be used as it streams into your enterprise in order to maximize its value. So in some crucial applications like nuclear power plant reactors, the velocity of the data processing need to be very high. So every day so many kinds of data are generated and analyze, if we'll say 500 million daily call details recorded in real time, predict customer churn faster. So every day so many companies are recording audio or video calls to understand, to get business intelligence from your data. So large amount of data is stored. So if the processing speed is slow, then it will not work. Now coming from 3 to next 5 V's. This is very important. We have discussed volume, variety and velocity. 2 new views are V's are introduced here. One is value and one is veracity. In your university syllabus, the topic is 5 V's of big data, not 3 V's. But I will cover today 6 V's of data as well. So I am talking about 4th V, that is veracity. It is a degree to which data can be trusted. From reliable sources the data is coming or the data is fake in nature. And the value, extracting meaningful data. How you can extract the data if it does not have any value. So data is not meaningful, like you are working on medical application and the data is of engineering application. So that should not be of any value. The data should be meaningful in nature. This is the 5th V. So you have to remember these 5 V's very carefully: volume, variety, velocity, veracity, as well as value. Okay, now I am covering the 6 V's of big data. Even it is not given in your university syllabus, but you should be aware about it. 5 V's we have discussed: volume, velocity, value, variety and veracity. 6th V is this one, variability. It is very important. The data should be variable in nature. It should be updated regularly. The data should be changing in nature. The model in which the data is stored or organized should be updating every single day. The data should be linked with the real-time data statistics. So the data should be variable in nature. Maybe you can say the dynamic data. Data should not be static in nature. If the data is static in nature, that should not give you the dynamic result. So the 5 V's, it is 6 V. These are the 6 V's of big data. Variability. Variability means the changing nature of the data. So you remember at least 5 V's of big data and the 6th one is the variability. Again, it is a pictorial representation of big data versus small data. So if I will talk about business value goes from low to high here and the complexity of the data goes from low to high here. Then the business intelligence part. This shaded portion of the graph means as soon as the business value goes high, the complexity also increases. But at a certain level, we can draw business intelligence. We need not to go ahead from this point or ahead from this point. But if I'll talk about predictive analysis, not only business intelligence, predictive analysis means predicting something on basis of some past experiences like medical disease prediction, emotion prediction, data mining prediction. So cryptocurrency is one of the example, predicting the amount at what speed the cryptocurrency is increasing. So data mining and predictive analysis go. So if you want to process such kind of application, the complexity again increase by this amount. So the data should be very high complex as well as the business value is very high. The data is increasing in complexity means the data is increasing in the business value. Both are directly proportional to each other. If the data is of less complexity, its business value is also less. But one more point, it is again difficult to process the more complex data. It requires more time to process the data. That is why only very large scale organization can do such kind of task. But business intelligence can be performed by middle or small scale organization. Okay, this is one more comparison between big data versus small data. Big data is more real time in nature because it is accurate data. 5 or 6 V's are ensured in this data. But in the traditional application which are generating small data is not of much use. So big data architecture. Traditional architectures are not well suited like general data structure, stack, queue, linked list array. They are not suitable. For big data architecture, we need Hadoop, MapReduce, HDFS. Such kind of architectures are required to process the big data. It is massively parallel processing. Scale out architectures are well suited for big data. Large scale architecture, cluster computing, distributed computing is required to process the big data. You can see with the help of this graph, big data analytics is exponentially more high as compared to data warehousing and data mining application. Data mining and data warehousing applications are growing at a very small speed as compared to if we'll talk about big data analytics. So accelerating time to value graph shows that as soon as the time increases, the business intelligence increases, the value of the data increases, and overall big data analytics is increasing. But there are few challenges with it as well. Big data, to handle the big data is itself a very big challenge. On what kind of softwares or hardwares we need to process the big data, it is a very big challenge. So the bottleneck is the technology. What kind of technology you should use, either hardware technology, software technology, networking technology. This is the real challenge. So new architectures are required, new algorithms are required, and few techniques are also needed. So this is a bottleneck. Another bottleneck is technical skill. Large technical skills are required to process such kind of big data. I am showing you an example of few big data companies which are dealing nowadays. These are the few examples like Oracle or SAS or some another Facebook, Hadoop. These kind of technologies are utilizing big data, and the major players are Google, Hadoop, MapReduce, Mahout, Apache HBase, and Cassandra. These are few of the companies which are dealing with the big data, and the modern big data tools are NoSQL, MapReduce, storage, servers, and processing. These are the few basic tools which we'll cover in the coming lectures, like NoSQL, the structured query language, the MapReduce is the mapping the data to the cluster and shortening them. Storage means the how to store the data, what kind of servers are required, what kind of processing is required. So at last, I'll cover few questions for you, the questions of the day. What is the smallest and the largest unit of measuring size of data? I have shown a chart in my second slide. You can check from that. But before that, you need to answer it by yourself. How big a quintillion measure is? Give the example of the smallest and the largest entities of data. You need to give the example what is the largest and the smallest entity, and give 5 parameters with which data can be categorized, like simple data, moderately complex data, and complex data. You need to give 5 example of all 3 categories of data. So these are the few questions based on today's lecture. You need to write in your notebook or you need to discuss with your friends. So in the next class, we'll continue with the second lecture of this video lecture series. Okay students, thank you very much. There is one more question. You can also go from this. Okay, thank you. See you in the next class. Good day.